So a full stack engineer social media API integration and analytics platform is what we're going to be building today. If you guys want me to build this for you out completely, please let me know in the comments. And if you're a business owner and need something like this built up for you, please also click the link in the description, jegnia.com, and I'll put in your inquiry. All right, let's get into the video. All right, so this is a full stack engineer social media API integration and analytics platform. This is a job from Upwork that I'm reviewing, and I'll be making. Well, first I'll go through the description, and then we'll go into how I would implement this and how you can as well. So we're looking for an experienced full stack software engineer to be able to primary technical owner of a 6-week social media analytics and monitor platform project. The project we are building is a centralized platform that integrates Instagram, Facebook, and X/Twitter to help an organization monitor and analyze social media activity. The platform will connect to Instagram, Facebook, and Twitter, collect posts, comments, DMs, and public social media content, monitor public content based on keywords, store and normalize social media data into a centralized database, use AI to classify sentiment, urgency, topic, and location, trigger alerts for important urgent. Integration is a key part of this project. Urgent content provider web dashboard for monitoring, filtering trends, and report social media integrations is a key part of this project. Depending on platform limitations, integration may use official APIs of third-party data providers such as Apify and potentially browser automation. What you own, you will be the main engineer, technical owner, working directly with the project manager. Your responsibility include design the overall technical architecture for the Instagram, Facebook build, data ingestion pipeline, handle API authentication, rate limiting, retries and failures, design the database and backend API integrations, large language models, AI APIs for classification, build the analytics dashboard, implement alerts and background jobs, deploy the application, set up basic monitoring, support testing, UAT, and production launch. Additional engineering support can be brought in if specialized help is needed. Skill, we're looking for a strong experience with React, Next.js, Node.js, and/or Python, PostgreSQL, REST APIs, and third-party integrations, background jobs, data pipelines, cloud deployments, building production web applications end-to-end, highly valuable experience. Metagraph API, Instagram, Facebook, else, yada, yada, yada. Web scraping, Playwright, Puppeteer, OpenAI, Gemini, Redis, queues, availability, ideally 30 plus hours a week, potentially extension, ongoing maintenance after launch. We're looking for someone who can own the technicals. Okay, so they're just a social media dashboard full stack application is what they're looking for in summary. So yeah, this is kind of like the proposal. We'll go into the implementation now. So this is a very extensive application, and I'll just teach you guys how to actually create a full stack application. I'm a full stack software engineer, so this is kind of like right up my alley, and the experience required for it is kind of matches what I do. So let's get into it. So for this implementation, what you will have is production-oriented vertical slice that receives authorized social events, perceives the raw evidence, normalizes platform data, applies a free keyword gate before metered AI classifications, and creates traceable alerts that the analyst can acknowledge and resolve from one dashboard. So our primary stack is going to be a Next.js, TypeScript. So Next.js is basically a front-end like backend type of framework that we can easily use. It uses React under the hood, and it's really easy to make applications with that. Fastify is just so Fastify is just basically API framework for Node.js. Helps build RESTful APIs. PostgreSQL is our database. Redis BullMQ is our queue. So I'll go into more of these later. S3, Meta API, X API for like our social media stuff. So the first working result, when the Sidebar Connect account receives a comment or matching public post, the same webhook poll pages or provider data set is replayed. A watch rule matches relevant text, and classifier marks an item urgent. So those are kind of things we're looking for. So this is like the high level approach of how we're going to be doing this. So platform adapters, Meta, webhooks, Xstreams, and any other providers that we're going to be having. Durable ingest. So this is where like the Postgres, Redis, BullMQ all come into play. Signals pipeline is a keyword rule, AI classification, And then so basically the durable ingest goes into the Postgres and the object store, and then the signals pipeline goes into the alerts and analyst groups, and this is kind of how they all work together. So this is kind of also the document also describes the scope of work that you'll be doing over a 6-week period and things like that, and kind of teaches you kind of like the timeline of how it should go down, right? This document will be available in my free community, so you can just go down there, you can download everything, and you guys can join and ask me also any questions as well. All right. So write the capabilities matrix for writing adapters. So these are some of the capabilities of the things we will be using for the social media side of things. So first we have to create these components first. So Next.js dashboard, we can just go into the website and we can just go through each one, and I'll just show you kind of no, you don't have to use it Next.js Vercel. You can host it anywhere, but Next.js. So this is the React framework for the web, used by some of the world's largest companies. Next.js enables you to create high quality web application with the power of React components. So if you don't know what React is, that's another front-end application. So you come in, you can go through these and kind of see where you can start using this. So once you get started, you can get into the documentation for Next.js, and it provides a pretty easy start, like kind of a guide for how to get started. So you create a new Next.js application, and then you'll have like the first running application once you go into your local host, right? So that's Next.js. And then when we go into Fastify, so we can go also to Fastify and look what we have there and what we can learn from there. Fast and low overhead web framework for Node.js. This also has documentation. It's a little bit easier. So once you have your npm packages, which is just your package handlers installed, you can go into npm install Fastify. If you don't know how to install your Node packages, search up how to install npm. Depending on your platform, you can just go in and npm install globally npm, and then get that, and then you'll be able to install the Fastify framework. And this just makes it very easy for Node.js to build out RESTful APIs. So like if you wanted something like getting a bunch of posts or something like that, we would hit this Fastify endpoint, and then it would be able to retrieve it very easily. Just the way you write it and how it's set up, the framework is very easy to use. So we have webhook gateways, which is really important. Poll stream workers. So polling and streaming is basically polling is basically once there's data available, you can poll at a certain interval. So if you wanted something like polling at like every 5 minutes or something like that, and getting the latest post, you'll be able to poll it. And then streaming is passing in information, right? So streaming is pushing information into database or pushing it somewhere, and yeah. So for that, like the boundaries are per source queues, quotas, checkpoints, and boundary backups. So and PostgreSQL is basically our database. We can also look at that for fun, right? PostgreSQL. You can either set it up as your own like server, set it up on AWS or something like that, or you can also use something like Supabase. I'm sure it would work fine for this application. Next will be Redis and BullMQ. That's actually very important. So Redis is yeah, so this is an in-memory database. Well, I've never actually been on the site for a while now. So and BullMQ kind of works up on top of that. So this is basically a queue. So a queue is useful for well, we can use Redis as a queue, and it's useful for like setting up jobs asynchronously, like async. So like you can push work into a queue, and then it would kind of wait in that queue until and then processed by some sort of worker or something like that. So essentially, for this, like if we wanted to gather count like how many posts are being created. We can continuously push it through the stream instead of aggregating the results um, like all the time or whenever a request is pushed through. We can push it into some sort of queue, and then the queue pull the worker would count it, and then add maybe push it to the database or something like that, and then increment the count. And then it's better for like big longer processes. Like if we're processing an image, we would put up a job to maybe edit this image or process this image in some way, and then a worker would pull that and then process it at its own time. So you can do a lot of work also. You can have multiple workers working at the same time, and then push that into like the workers, and then multiple workers can work on various different processes at the same time. So it's useful for that. Where were we? Next is object store. So object stores are basically you can't just simply store any big files or images on like Postgres or something like that. It would make it extremely slow. So we always reference it with the object store, such as S3 or any other object stores. I actually don't know many other things are just built on S3. So like a lot of like AWS S3. If you go there, you can also see what that's available there. So the cloud storage here, a lot of things like Superbase's storage is based off of S3 as well. Or am I making that up? Let me just check that out. So storage S3. Now supports the S3 protocol, is now pushing S3 compatible storage provider. Well, it doesn't matter, whatever. You use Superbase storage as well, so a lot of options here as well. Okay, next we can go into, these are some of the secret keys that are configurations that you would need to bring in when you're setting those things up. So first is prove access before. These are the steps that we're going to be kind of going through. So prove access before building the platform. Your goal is to turn provider assumptions into tested evidence during the first 2 days. So we're going through the developer apps, whatever apps we're choosing, test accounts, and then minimum scope and one sample event, and then we can archive the proofs. So create a capabilities role for every requested objects, and these are some of the things that we can create. And then record authenticating mode. Use least privilege OAuth, and then set an explicit fallback for each block capability. So this is kind of like your first minimal viable. So it's like a subcategory of a MVP. Create the durable social data ledger. So that this would be separate raw provider evidence, normalize social objects, classification, and analyst cases. So we get a raw event inbox, normalize the object, rule match, and then classify, and then alert cases. So these are some of the tables that you would make. So social connections, ingestions, social objects, and then rules or watch rules, classification, alert cases. And then you can also go to the next step. So receive webhooks and pull safely. So next, your goal here is to acknowledge providers quickly while preserving enough evidence to process asynchronously. So verify the signature, insert raw inbox row, respond with a 200. 200 is like, yeah, like you did a good job and it worked type of thing. And normalize in a worker. Normalize in a worker. Expose separate meta verification events, verify the challenge tokens on setups. Return success only after the raw events is durably inserted. Do not call the models, set alerts. For X and provider pulling, persist the last confirmed cursor only after the page has been stored. Rerun overlap and windows so late items are recovered safely. And then normalize without losing platform meaning. So create one search model while retaining platform specific evidence and semantics. So adapter payload, canonical event, social object obserts. So this is the object that you would kind of get. So it highlights which platform it's on, the object type, whether it's a message, a comment, and then so you're just normalizing the data that you receive from the platform. Next is filter first, then classify with evidence. Your goal here is to spend model token only on content that passes a deterministic watch rule. So once you normalize the text, keyword or author rules, classifier schema, policy threshold, and case decisions. Yeah, so you go into that. This compile exact. So this is kind of the instructions. You should see by the end of that, unmatched content is searchable, but creates no model request. Matched content has rule evidence, a schema valid result, and a deterministic case decision. So next, it will go into a make alerts a durable analyst workflow. So alert wants preserve delivery evidence and require a named operational outcome. Case open, route selected, delivery received, acknowledge, resolve, or suppress. Yep. Yeah, you should see replaying a worker produces no duplicate. So it's really important to create events that do not occur multiple times. So whether that's using some idempotent key or something like that to make sure that these events don't happen too many times. Build a dashboard around triage and evidence. Your goal is to give analysts one fast path from signal to source evidence and disposition. So inbox, filters, detail drawer, acknowledge, assign, resolution, and trend reports. So these are kind of the things that you would probably need, which a live inbox. So this would be where news cases, severity, SLA, platform and owners, filter, and paginating without cross-tenant leakage, evidence view, search, trends, rule admins, and reports. So these are kind of the endpoints that you would want to use. So I'll give you a quick summary of how these what these actually mean. So a get endpoint is to retrieve information, whether that's like search criteria or like a certain post or something like that. And then post is actually something that you're posting to like a database or something like that. And then patch would be updating like a field in a database or something like that. So those are kind of the two HTTP requests that you can make in a RESTful API. Proof failure and handling before that. Yeah, so this is kind of the failure things that you can look out for. And then this is overall the kind of workflow that you would see for like failures and stuff like that. And these are a little bit more technical documentation. And yeah, so these are some of the setup references that you can use. It's really important that you can go through this. And if you have any questions, let me know. If you also need something built out for you, please let me know. If you're a business and you need something built out, send me a message in jagnia.com/inquire. There will be a link below. And if you guys need this documentation, go to my free school community. That's also in the link below. And yeah, thanks for watching.